question 11C from the 18 homework reviewed 3 for integral calculus, and this is under the volume section. So 11C says we have an area R bounded by the x-axis, y-axis, and f of x equals 2 minus e to the x. So that curve is 2 minus e to the x. And it says, part 1 says find where the graph intersects the x-axis. So to find out where it intersects the x-axis, I just solve the equation equal to 0. So I end up with 2 equals e to the x. Solve for x, x is equal to log 2. So that point where it intersects the x-axis is x equals log 2. So that represents one of our bounds. Part 2 says the area of the base R is made from a solid whose cross-sectional areas perpendicular to the x-axis are squares. So basically we're taking this section here, that line there, is going to generate a square in 3 dimensions. So I don't know how to draw that. I'm going to draw that out kind of like that. And so we end up with this square sticking out of perpendicular straight out of the graph, and it's going to generate a solid as I stack those squares up. So I'm going to find, first of all, the area of the square, and I'm going to integrate that by giving it some thickness, and I'm going to integrate that from the lower bound to the upper bound. So that's going to give me the volume of that solid. Okay, to find the area of the square, I'm just going to take the y value and square it. So I have my f of x as my y value. So from 0 to log 2, I'm going to take 2e to the x, square it to get the area, give it some thickness, and then add it all up. So I've got set up my integral. I'm going to expand this so I can integrate this a little bit easier. 4 minus 4e to the x plus e to the x squared, or 2x, and then multiply that by dx. Now I have an integral that's a little bit easier to work with. So integrating this, I get 4x minus the integral of e to the x is itself, plus the integral of e to the x is itself, but because of the compression times 2, I have to divide by 2, and then log from 0 to log 2. For the volume, I just substituted in. Volume is equal to 4 log 2 minus 4e to the log 2, which is 2, plus e to the 2 log 2 over 2 minus, I better just bring that down a little bit to make sure you can get all stuck together. Okay, just bring that down. So I'm going to minus, substitute 0 in, I get 4 times e to the 0, which is 1, plus e to the 0 over 2, and it looks like that. Okay, and then I can just simplify that expression. This becomes 4 log 2 minus 4 times 2. This is going to become 2 to the power 2 log of 4, so this becomes plus 4 over 2. Okay, and then minus, this is going to be plus 4, and that's going to be minus 1/2. Simplifying that all out, I end up with 8 minus 4, 8 plus 2 minus 4. That's going to be, so I'm going to get log 2, 8 plus 2 minus, or 8 plus 2 plus 4 is 8 plus 6, so negative 2 minus 1/2 is negative, or minus 2.5. And this will be in centimeters cubed. For part 3 says that the cross-sectional areas are now circles. So I take that same graph, I take that intersection, this is going to be log 2. Now this cross-sectional area ends up being a semicircle, or a half circle. So to get the volume of that shape, we're going to integrate from the same bounds. Now I need the area of the circle, so pi times r squared times the thickness. So there's r, there's r. So we know that r is going to be half of the height. So then if I substitute back in, so instead of using r squared, I'm going to take the height of that expression, which is 2 over e to the x. I'm going to divide it by 2 to get the radius, and then I'm going to square it. Okay, so that expression divided by 2 represents the radius. Okay, so the whole height divided by 2, and I square it, and then I multiply it by dx. So now I have my integral. I just need to work that out. Pi from 0 to log 2. Expanding that gives me 4 minus 4 e to the x plus e to the 2x all over 4. That's times dx. Okay, so I can do this a few different ways. I'm going to leave that 4 in there maybe and integrate this. So my volume is equal to pi. The integral of 4 over 4 is going to be x, just 1x, minus 4 over 4, that's going to be 1, so the integral of e to the x is e to the x. This is going to be e to the x, 2x divided by 4, so the integral is going to be e to the 2x, divided by 4, and then divide by the 2, so I'm going to get divide by 8. There's my integral, and then I'm going to put my bounds in from 0 to log 2. Okay, so that's my integral. I calculate my volume by substituting in. I'm going to get log 2 minus e to the log 2 just becomes 2, plus e to the 2 log 2 is going to be e to the log 4, so it's going to be 4 over 8. Okay, then I'm going to subtract. I'm going to substitute in 0. E to the 0 is 1. E to the 0 is 1. So I end up with this expression. Okay, so then working that out, this becomes pi, and simplifying that out, that becomes, maybe I'll just do a couple steps here, log 2 plus 1/2. So negative 2 plus 1/2 plus 1 minus 1 over 8. Okay, so when simplifying this out, I get log 2 minus 5 over 8. Okay, I think I made a bit of a mistake here though, because I think when I set this up, I only wanted a semicircle, so I have to divide by 2, divide by 2. The good thing is that this is, since I can just take half of everything, I could just put the divide by 2 on the outside of everything. So there's my final answer. Okay, so if I include my divide by 2 for the semicircle, that is the full solution. So don't forget that divide by 2.